We are joined by Miguel. Hello, Miguel. And hello to everybody else who has been sitting here and um, being very kind and looking at my students. What is that photographs? Let's transition into learning more about the Big Read Selection Lab Girl by Hope Jahren and the ways in which we can teach this book using the scientific method and data visualization. So hello, everybody, and welcome. I'm going to share my screen and bring up a presentation in just a moment. And here we go. All right, so welcome everybody to The Story Behind the Data, Lab Girl Edition. This is a professional development brought to you courtesy of NEA's Big Read and the Poughkeepsie Public Library District. And Joel Ratzlaff, of course. Hello, Joel. Yay. Thank you, Joel, for bringing us here together and also for all of the work that you do behind the scenes. Lab Girl is a fascinating book, and it is both beautiful and challenging. So I think that for teachers of grades 9 through 12, this would be an excellent selection for your fall curriculum. And in order to help you think through the multiple ways that you can teach this book, today we are going to be talking about how you can use scientific approaches and teach data visualization alongside Lab Girl and help students get a really rich, robust understanding of what we mean when we think about stories and information. We have a couple of norms that we want to share, which will be guiding our behavior for the next 2 hours. India, would you be so kind as to read the first one for us?
Gladly. All right, formalities. This session is being recorded and will be available for future reference. At the end of this course, a link will be shared in the chat box to a Google form for attendance verification and general feedback.
So please keep your microphones muted unless you are speaking. And we would love for your video to be on unless you're having technical difficulties or need to step away for just a minute. And please be patient if there are any kind of technological glitches or issues that arise. It happens to the best of us that you're in the middle of talking and then all of a sudden you go, and then you just stop for a minute. Those are not intentional glitches except for that one I just did right there. Those would just be somebody's internet being a little bit slow. So hang in there and we will get to everything that we need to do today. And India, will you take the next one?
I will. So we ask you to please stay engaged, to remain emotionally, intellectually, morally, socially involved in the dialogue. And do you want me to take the last one?
Sure.
Yeah. And we also would like to foster a collaborative culture. So please feel free to share ideas so that learning can happen and lessons can be made better. Bouncing teachers, teaching teachers.
Yes. Yeah. Love it. Yeah, we're really excited to dig into this with you. So a little bit of background information. I work for an organization called The Artifact, and using digital apps to create digital art is one of my specialties. And so I am here today to help with the thinking through of how to teach literature and how to teach science through artistic expression. And India, do you want to introduce yourself too?
I would. My name is India Futterman, and I am the Education Program Specialist at Carey Institute of Ecosystem Studies in Millbrook, New York. We are a research and education institution, and one of the big things that I do is teach data literacy and data visualization. So Mary Ellen and our respective fields go very well together. So I will be getting you all excited about data, because that's what I do.
That's what you do. A little bit about the path that we are going to take for the next 2 hours. Excuse me. We are going to do a quick overview of Lab Girl with some general information. We're going to read through an excerpt so that you get a sense of how the things that we're talking about really come together through Hope Jaren's prose. We are going to learn a little bit about what data visualization is. We're going to go through some very quick warm-up activities that you could do with your students to help them wrap their minds around data visualization. India is going to talk to you about the scientific method and about the artistic expression of the stories contained in data. And then there's going to be some breakout time where we introduce you to some apps and websites, and we give you a data set and some facts and statistics, and then give you independent time to play around with the apps and see which ones you like. And if you have any questions, we are here if you get stuck. So let's jump on in, shall we? So can I get a quick show of hands? Who has already started reading or has read Lab Girl? All right. So we've got some folks. And if you haven't, that's okay. I found it to be a pretty quick read. It is a memoir, which means specifically that it's an autobiographical narrative that focuses on the life of the author, but in relation to a specific issue or movement or social context. And here it's science. Her specialty is paleobotany, so studying the evolutionary history of plants. The book itself is divided into 3 sections. The first section is called Roots and Leaves, and that really is kind of the early years. It covers her childhood, her introduction to the world of science, her early memories of being inside her father's laboratory, her first experiences being a woman entering the world of science and encountering some specific challenges and hardships there. The second section, Wood and Knots, covers her early career as a scientist and a professor. It sort of sets the stage for what her everyday life is like working in a university lab, and it also covers her mental health. There is a fascinating and harrowing series of chapters where she narrates a mental health breakdown using the second person. So it's all, you experience this, you wake up on the floor, you can't make sense of things. It is very effective and yeah, very scary. I think that teenagers might really relate to that section in particular. This section also has a road trip that sort of exemplifies her decision-making challenges when she's having a mental health breakdown, which is both hilarious and just riveting. So that might also be a good section to read with your teenage students. And then finally, we have Fruits and Flowers, which is the final section of the book that covers Hope Jaren's later career and her marriage and her experiences with motherhood up to the present day. Interestingly, she says that having a child helps her be a better scientist, which is, to me, just fascinating because many mothers, I think, feel a sense of chaos when they're dealing with an infant. For some reason, it just settles her and makes things much easier for her. We should all be so lucky, right? So there's kind of maybe an element of fantasy in this book as well. Hope Jahren talks a lot about data, and she uses a lot of different literary elements to try to bring the data's story to life. So this is not a book where she covers the numbers and the data specifically. This is more about her experiences in collecting the data, her experiences in teaching classes where she trains students how to collect data, her experiences being broke and trying to find grant money to fund her lab so they can continue collecting data. So this is about her relationship to the world of science, not so much about giving us specific data sets. But she does talk about data a fair bit. You know, she makes a lot of conclusions, and then she uses those conclusions to paint us a picture of how the world looks through her eyes. And one of the ways that she does this is by something I like to call the chapter switch, where every other chapter, it's either a short kind of poetic musing that is not located in a specific place or time, where she talks about elements of evolutionary botany. For example, there is, at the beginning of chapter 3 in Wood and Knots, page 104, she says, "Plants have far more enemies than can be counted. A green leaf is regarded by every living thing on earth as food." So, you know, she's sort of waxing poetic about different facts about the natural world. Those chapters are pretty short, and they alternate with longer chapters that are sort of autobiographical exposés. These autobiographical chapters are very anecdote heavy. They arrive in chronological order, and she narrates specific events with a lot of fictive embellishment. She writes dialogue for herself and her students and her lab partners. Did she have a recorder there? I don't think so. She's just sort of approximating what she remembers probably was said. So she's talking about facts of her life, but there is a lot of fictive embellishment going on. And we'll see what that looks like in just a second when we look at an excerpt. There's also a lot of anthropomorphizing in this book. That's another way that she helps her readers make sense of the massive amounts of data that she collects. She casts all the different plants and trees that she works with as though they have human characteristics. Willow trees, for example, on page 90, she casts in the role of a Disney princess or a Grimm Brothers princess, where she says that willows are like Rapunzel. This tree appears as a graceful princess bowed down by her lush tresses, waiting on the riverbank for someone just like you. And, you know, that is a pretty fanciful way of looking at a willow tree, but also it really helps you sympathize with the willow tree, and it helps you understand that she views plants as people a lot of the time. There's also a fascinating chapter on trees remembering their childhoods, which isn't quite the way that it sounds like. It has to do with the rings in tree stumps indicating that a tree didn't put out as many leaves because they went through a cold snap when they were very young, and so they're conserving resources. And, you know, it's a series of chemical reactions, but it's also nice to think of it as trees remembering their childhoods. So going along with that, there's a lot of similes and metaphors, which would be great for, you know, ELA contexts, having students just sort of hunt through and find some. And then finally, this is just a general warning that there is some adult language in here. There's a couple of F-bombs. There's a couple of times where she and her lab partner call each other dumbasses. There is a fair amount of colorful language. So it's on par with something like Catcher in the Rye. So if you are in a district where a book like Catcher in the Rye is okay, I think that Lab Girl should also probably be okay. But just so you are aware that if you do this with teenagers, there might be a lot of giggling once an F-bomb is dropped. And so why do we want to teach data visualization in an ELA context or alongside literary studies? It struck me when I read Lab Girl that there are many parallels to different aspects of the literary world. For example, on page 24, she says, "A definitive data set made with integrity and interpreted honestly is the most innocent thing in the world." And of course, that made me think of, you know, Hamlet. There is nothing either good or bad, but thinking makes it so. Data is in itself just information, fact, truth. The ways that humans interpret it and analyze it and then report on those findings, that's where it gets a little more subjective. So data, again, doesn't really have an agenda of its own. The human beings behind it are the ones doing the work of using data for one or another purpose. So our guiding questions are really just, what is data? Where do we find data? How can we best visually communicate data to a general audience who maybe wasn't there with us out in the field when we were collecting it? Hope Jahren has some ideas. We have some ideas for you to train your students on also. So this is the part where if you have a book, I'd love for you to turn to page 106. And if you do not, we have a PDF. Data visualization, or the act of visually communicating what data is saying, or the story behind the data, the meanings behind the data. It's something that Hope Jahren does a lot, but she doesn't necessarily use that word to describe it. And I want to show you the ways that she helps the reader visualize data without having infographics inside of the book. So we are going to quickly go to an excerpt. And you can read aloud from the screen if you would like, or you could read aloud from your book. And Ashley, I already kind of suckered you into being one of our read alouders. So if you would please be so kind, can you read us the first 2 pages of this chapter, and then we'll have someone else pick up.
Sure. There's some cicadas in the background, so just interrupt me if you can't hear me.
Nature. Yeah, evolutionary biology. It's a perfect backdrop.
Soil is a funny thing in that it isn't really anything in and of itself, but is instead the product of 2 different worlds coming together. Soil is naturally produced graffiti that results from tensions between the biological and geological realms. Back in California, Bill and I decided that we would teach our soil class differently from the way it was taught to us. Instead of just filling out forms and cataloging data, we would teach where soil comes from and how it forms. We'd make students really look at it, touch it, draw it, and come up with their own improvised labels for what they saw. We developed a teaching protocol that goes like this. We simply pick a place and we dig. We dig the earth open until we can see it whole and naked from top to bottom. We expose what was unexposed and force its secrets out into the open. All around us, we can point concretely to what's alive: a green leaf, a moving worm, a sucking root. At depth lies cold, hard rock. old as the hills to our right and left, and equally devoid of breath and movement, not alive. Everything that is physically located between the two extremes, alive and not alive, we call soil. At the top of the soil, the influence of the living is most obvious, dark brown, rubbed from the residue of dead plants, wilted and rotten, mixed into a slime that seeps and stains everything around it. The bottom of the soil is dominated by the rock's legacy. The waters of the ages have dissolved the rock little by little, churned it into a paste, and dried it over endless cycles to yield a slag that is distinct from the undamaged rocks that lie below. In the middle, these two substances interact, sometimes blooming into the garish streaks of color that so struck us when we drove through southern Georgia.
All right, thank you, Ashley. I'm going to stop you there and pick on India. India, do you want to read the next bit?
Sure. I'm going to read the next 4 paragraphs on the page, right to the almost bottom of the page.
Yes, that'd be great. Thank you.
All right. Bill was born to tirelessly evangelize soil using his God-given talent for marking the subtleties of chemistry, the shading of colors, and the twitches and texture that only he can see from within a hole. He can compare the dozens of soils he carries in his memory with the one before him in bafflingly excruciating detail. All reserve is shed when he talks about soil, and I have watched him deliver many dramatic monologues in Irish pubs, perfectly sober, describing how the discovery of new colors in his new combinations underground is what he loves most about his work. In the summer of 1997, when I was born, we took a group of 5 students into the field to teach them how to characterize and map soil. The trip was a first-time experience for 4 of them, and a repeat trip for the undergraduate who volunteered many hours in my lab each week. Bill had warmed up to this guy, and I had also, and so we invited him to come along on each of our research and teaching excursions. The best way to prevent people from complaining about food while camping is to force each one of them to take responsibility for one night of cooking, and our undergraduate mascot had eagerly volunteered. Desperate to impress us, he had bought cans, boxes, spices, and a bag of potatoes that he peeled and then boiled until soft. But he was only able to start cooking at about 11 p.m. after we finally arrived at the campground. Boiling water on a campfire is torturously slow, and so I was dismayed when, after removing the cooked potatoes, he set another huge pot of cold water over the heat to boil. Instead of just doling out the potatoes with a fork, which would have been haute cuisine by our standards, he instead began to mash them, adding a fine milled flour that had appeared from his backpack. I noted with alarm that the cooking process was starting all over again, and I asked him what he was doing. I am making Hungarian potato dumplings, he explained. My grandmother used to make them. Trust me, you'll love them.
All right, I'm going to take the next section. Thank you, India. We ate at about 3 in the morning. Hey, you should start going by dumpling, I exclaimed as we finally sat down to eat, and the student's face lit up. He was delighted with the professional intimacy that a private joke implied. I will not refer to him as Dumpling, Bill said with a masculine scowl as he bent over his soup. He was tired and hungry and not in the mood. The warm night air was perfectly still, and we could hear a chorus of frogs that were croaking somewhere in the darkness. We all ate in silence, stuffing ourselves with the delicious dumplings that had been prepared in ridiculous abundance. While we were cleaning up, Bill was the first to comment, "Good dinner, Dumpling," he said solemnly while gathering up the empty bowls. Whatever the student's real name was, I have since forgotten it, for it was never used by any of us again. I've also never eaten anything that tasted as good as those dumplings in all my years since then. We were digging in Atkinson County, which, although it does not seem notable for anything, we referred to as Nirvana because of its exquisite soils, unequaled within the 49 other states and 5 continents we have traveled. We found it the same way that we found so many of our teaching sites, from the car window. If you drive across the state of Georgia, from the Piedmont Plain near Atlanta, southeast towards the Atlantic Ocean, you will find yourself driving along a river of red dust that was rubbed from the residue of what might have been mountains in some ancient geological dream. While driving on Highway 82 towards the Okefenokee Swamp earlier that year, we had seen what appeared to be buckets of rich apricot paint thrown across a ditch of creamy sand. In those days, Bill required a cigarette frequently, and so we were in the habit of stopping often to inspect the landscape. When we pulled over near Willacoochee, The paint turned out to be the rusted iron band within a rare oxisol soil type, and we immediately decided to include the stops in our soils course. When we arrive at a soil site with students, we first unload the shovels, the picks, a tarp, the sieves, the chemicals, and a big blackboard with colored chalk. We dig a hole, down deeper and deeper until we hit hard rock. Careful to stand only on one side so that everybody is looking at the same thing. Once we have dug deeply enough, we dig away from the profile, opening a pit that is large enough for 3 people to stand in, and from which we can make an evaluation as to the lateral continuity of the soil's properties. This digging can take hours, and if the clay is thick or if the soil is waterlogged, it is particularly exhausting. Jewel, would you like to read the next few paragraphs, please?
Sorry, I don't have a copy with me.
It's okay. Are you able to look at the PDF that's on the screen?
It's not on the screen.
Am I the only one seeing the PDF on the screen? That's
Nope,
some
I see your PowerPoint, not your PDF.
Oh, okay.
Also
You know
don't
what?
see the PDF, yeah. Sorry, we didn't let you know.
That's okay. Check this out.
Woo!
How about now?
There it is. It's a little glitchy, but now we're good. Perfect.
Okay. Jewel, can you please start with Bill and I dig together as a sort of waltz? Thank you.
Bill and I dig together as a sort of waltz, with each one of us throwing and the other catching. One person chips the ground with a pick, while another positions one shovel below to catch the debris. When that shovel is full, it is swapped for another, and the original one is emptied to the side. Unlike holes that are dug for construction purposes, the fill must be carefully piled to the side in order to keep the bottom clear and provide a view all the way up to the top of the hole. Even as we avoid compressing the soil profile, there are always stray students who we notice standing on the top and looking down on us, and we shoo them away like chipmunks at the campground. When we ask for digging volunteers, we are occasionally taken up on the offer by what inevitably turns out to be the farm kid of the group. But most students don't really want to dig. In the old days, they used to stand idly by watching us dig for hours, which peeved us. Now they turn sideways, surreptitiously searching for cell phone signals. Once we can see the new earth from top to bottom, we take pins, old railroad spikes that we painted bright orange, and insert them at the boundaries between what we think we see as layers. Bill and I argue about the direction of the sun and over whether each detail is real or just a shadow, and we work to convince each other of our opinions like lawyers in a contentious trial with no judge and a bored jury. Sometimes soil boundaries are distinct, as within a chocolate vanilla layer cake, and sometimes they are gradual, as the edge to middle change of red within one square of a Mondrian painting. Although they form a foundation for all the data that will follow, the number and placing of these soil horizons are the most subjective part of the exercise, and each scientist displays a slightly different style. Some, like me, feel we're creating modern art out of the landscape, preferring the result to be huge and whole, with as few rules guiding the eye as possible. We're known as lumpers because we tend to lump the details together as we work. Others, including Bill, are more like the Impressionists, convinced that each brush stroke must be executed with individuality in order to achieve a coherent whole. They are known as splitters because they split the subtle details into separate categories as they work. The only way to do good soil science is to put a splitter and a lumper together in a soil pit and let them fight it out until they achieve something that they both know must be correct because neither of them feels satisfied. Left to our own devices, the lumper will dig for 3 hours, mark the horizons in 10 minutes, and then go on our merry way. Left to his own devices, the splitter will dig a hole, crawl inside, never to be seen again. The splitters and lumpers are both productive only when forced into bickering collaboration, and though together they produce great maps, they rarely return from field trips still on speaking terms. Once the soil horizon demarcations have been successfully negotiated, a sample is removed from each layer, relocated to the tarp, and subjected to a battery of chemical tests to determine acidity, salt content, nutrient levels, and a growing list of field-ready chemical attributes. At the end of the day, all the information is transferred to the blackboard, graphed, and drawn. And a long discussion ensues about what visual properties and chemical properties and taken together imply about the fertility of the soil. Fertility being one of the most grandiose and imprecise terms that science has ever produced. The ideal educational field trip lasts about a week, with one new soil written up each day and about 500 miles of driving afterwards toward another site. 5 days and 500 miles provide enough time and distance to give students an idea as to how much soils vary across the landscape, and also to expose them to the thoughtful, rambling mindset necessary for soil work. By the end of the trip, they are either in love with the work or utterly turned off, and therefore have probably decided upon a major as well.
Thank you, Jewel. Thank you to all of our readers. So as you can see, what she's doing is narrating her experience in collecting the data, and she's giving the reader lots and lots of really rich details to help them visualize what she's doing when she stands in a pit and marks out different soil layers with railroad spikes. There's a kind of romanticism about it too, which I just love. And going back to the PowerPoint presentation, being that she spends so much time collecting data and she just rhapsodizes about the power of data and about the details of all the work collecting data, she is just really focused on her experience and anecdotes about her life spent in the field of data. So we thought that because data visualization is woven into the narrative of Lab Girl, it's a really great opportunity to, whoop, I'm so sorry, I don't know what happened there. My screen refreshed. Hold up, everybody. I'm gonna stop sharing for just a second until my internet comes back. Yeah, it's just a really great opportunity to teach Lab Girl as literature alongside science, alongside artistic expression. Now, if we, this is why we put the part about patience with technical glitches into the norm.
And I'm happy to share my screen if needed.
I think that we've got it again, and we're back. Although, thank you, India. Okay, so data visualization is something that Lab Girl kind of takes for granted. The importance of being able to take the numbers and all the measurements that she's taking in the field and then being able to illustrate why she's doing it, what the importance is, using flowery language, using visual metaphors like the cake. And so it's a great opportunity to teach students how to do the same thing. Data visualization is really just teaching students to be able to understand and visualize the meaning behind the numbers, behind the data, with infographics, with visual depictions, with graphic imagery. I heard once someone ask, but aren't, students too young to really be thinking about this stuff? And you all are high school teachers, so you might not have that question, but it still is a neat point to show, which is a birthday cake. A birthday cake with candles is a piece of data visualization. A 6-year-old who can tell you that they are 6 years old knows exactly why there are 6 candles on a birthday cake, because each one of those candles represents information. It represents a year that has passed. And so if someone can understand why candles are on a birthday cake and what those candles represent, they can understand data visualization. So just a couple of points about why we want to do data visualization and why it's so important is that behind the data, these numbers that you're going to be seeing that India will show you in just a minute, they represent facts. They represent truths. Whether it is number of candles representing the passing of years, whether it is a number of algae blooms at a certain point in a lake that scientists are measuring, whether it is the depths of certain soil layers inside of a pit that you have just dug. Numbers are just truths. And there's some kind of story being told behind those truths. There's a relationship that connects those numbers. That relationship can be examined and understood to make for a more robust understanding of the situation that we find ourselves in. And especially when those numbers suggest a correlation between phenomena and actions that people take, those numbers can change lives. Those numbers can point to a set of behaviors being really good that we want people to replicate. Those numbers can point to a set of behaviors not being so good for the environment that we want people to stop. Either way, numbers tell a story, and that story matters. Okay, so here is our first concrete activity idea, which is to warm students up into thinking about what data visualization is. We have a visual poll results activity. So what we would suggest that you do, and this would be, a very kind of intro level, fun and easy warm-up activity, and it works great for conducting virtually, as many of us face uncertainty about whether we're going back to classrooms virtually or in person this fall. You just ask a question to the class. Students love coming up with questions that they can poll their classmates with. You figure out how many people fall into what category, and then you figure out, how do I visually represent the fact that we have different people saying different things? So for example, if I had a class of 10 and I asked them, what do you prefer, hot dogs or hamburgers? If 7 people said hamburgers and 3 people said hot dogs, a very quick and easy way to visually represent that is by stacking up some emojis. But that's not the only way that you could visually represent those poll results. You could have a really big hamburger that is 70% bigger than a little hot dog. Or you could create a pie chart, and you could shade in that 70% of people prefer hamburgers. Once people understand the connection between the numbers and the story that it's telling about the class, the visual stuff tends to spark in their minds. You will have a chance to make one of these in our breakout portion a little bit later on, but for right now, these are just very quick and dirty activities to warm up your students into the world of data visualization. We also have something called a choropleth. So a choropleth is literally just a map that indicates information using color or some kind of color gradient. So a way to use this as a warm-up is to ask students to draw a map of their bedrooms or their house, ask them to choose a color, and then ask them to use that color to indicate where they spend the most time. So they would start thinking about their pathways on a daily basis through a room. They would start using colors or shapes to visually represent to someone who's reading it, where do I spend my most time? Now that's a pretty basic choropleth. You have probably in your own lives seen choropleths in a little bit more of a sophisticated way. We are probably sick to death of seeing choropleths that illustrate the number of COVID cases in the United States. But it makes for a really good and timely example of what a choropleth is. So here we have the darkest blue representing the densest concentration of confirmed cases on a color gradient going to white, where we represent the least dense concentration of COVID cases. And as you can see, when you color in a map, you start to see trends, or you start to see kind of patterns, places across the United States where the dark colors seem to sort of ripple out and get lesser. There's hot spots going on here. This is just a really cool choropleth that is all of the McDonald's in the United States and how close they are to each other. And again, if you look at it, you can start to make some interpretations, right? You can start to draw some conclusions. It really looks like the East Coast has just a ton of McDonald's, and that there are some places where there's not so many McDonald's. You might then want to draw conclusions about urban versus rural environments. Might be fun to do another map and lay it over and see if there are parallels between the two. But again, using concentration of color and a gradient to indicate information. That is what we have when we have a choropleth. And one of the breakout activities, which we will provide for you later if you want to do something really low key, is we have a blank map and we have a set of state rankings from a data set. And if you have colored pencils at home, you can just print yourself a map and do some coloring today, or you can take a JPEG and we will show you how to use an app on your smartphone or an iPad to be able to color it in digitally. And then, and this is maybe my favorite warm-up activity to visualizing data, is the plot graph. So this comes from another memoir, A Man Without a Country by Kurt Vonnegut, where Kurt Vonnegut takes the approach of looking at plots of stories as though they were scientific information and graphing them. So he starts with an XY axis where we have the X line that represents the beginning of the story and the end of the story, so time. And then we have the Y-axis, which represents a spectrum of good fortune to ill fortune. So good stuff happening and not so good stuff happening. And he takes a couple of different story archetypes and plots them out for the readers. So this is what he calls the boy meets girl narrative, where at the beginning, things are okay. Then the boy meets girl, or as I like to think of it, the individual meets the individual. Maybe boy meets boy, maybe girl meets girl. Maybe doctor meets patient. Maybe cab driver meets passenger. Maybe dog meets cat and the two of them have an adventure. Regardless, the first part of the story, as time passes, things are looking up. There's maybe a romantic montage with some happy, bright music. Maybe they go dancing. And then typically something happens and things go sour. Maybe there is a dark history in the past. Maybe the dogs have a gang where they don't like cats and they don't like that this one dog has just met a cat. Who knows? And then typically for this story, something happens that points things going upward again. Happy reunion. Maybe they figure out a way to solve the cat versus dog debate for good. Maybe the cab driver decides that he is going to retire and they're going to go find a cottage in the mountains. This is a story we've all seen before, right? It's basically a rom-com. But it's really similar to identifying trends in the data when you look at a data set from scientific observation. You know, it's all about just that measurement of what happens over time and noticing how one thing leads to another thing leads to another. The Cinderella story, according to Vonnegut, is that things start out bad. They start out bad and then incrementally there's something good that happens and then you plateau for a while. Then something good, then you plateau for a while, and something good. And then the highest point is probably going to the ball. You got that dress, your mice friends have been turned into chaperones and chauffeurs, but then midnight strikes, right? And things go way down again. That slipper is lost. You have turned back into a pumpkin. And then things are pretty bad again for a little while. And then things go up when the prince realizes who you are, the shoe fits, happily ever after, forever and ever and ever. There's a nice little infinity sign. This one just makes me laugh. It's the Kafka story. Things start out bad and then they get worse. But, you know, it's a fun exercise if you think of, you know, a movie that your students might have seen or a book that you just finished reading, thinking about what does the plot arc look like? What does the story look like if I try to graph it out? And that really helps them get their minds thinking if they are, for example, doing soil measurements over time. What does that story look like? Are those levels of specific nitrates, for example, rising over time? Are they rising and falling and rising and falling? What's going on there? That is a way to intrigue them and just pique their interest in the story that numbers are telling by helping them understand these stories in terms of graphs. So I've done a lot of mentioning of the numbers and the data. And even though this is, like I said, more about memoir and anecdote, this book, than it is about Hope Jahren giving us, you know, hard sets of numbers, there's a lot that can be learned from also figuring out how do I lead students through understanding the story behind those hard sets of numbers. And to tell you all about that, I'm going to hand things over to my colleague, India Futterman from the Carey Institute of Ecosystem Studies. Take it away, India.
Thank you, Mary Ellen, for that excellent first part of the presentation that oriented us really well. I want to do my own little ambient noise disclaimer. Myself is that I am sitting on my semi-closed porch, and there might be some traffic noises that you hear. I happen to live on a very noisy street that trucks and motorcycles barrel down constantly. So anyway, to sort of orient us in our data story part of the presentation, I want to refresh everybody's memories on the different steps of the scientific method and how they end up producing what we can think of as a science story. So the scientific method begins, of course, with an observation of a phenomenon. Say, cactus is growing faster in one desert than another desert. It's growing faster in the Mojave Desert than it is in the Gobi Desert, and it's the same species of cactus. Let's use that as an example. So then from that observation, we can formulate a question. Now, why is the cactus growing better in one place rather than another? That's an obvious question to ask, and it's an interesting question, but it's not an answerable question. There are an infinity number of factors that could be contributing to the growth of plants, as Hope Jahren talks about a lot in Lab Girl as well. And so when we are designing experiments and forming questions, we have to be really circumspect about how we're asking them and if they will be answerable. And so what often happens when we ask scientific questions is that we actually have to narrow and narrow and narrow our initial question down further and further until we can identify one or two variables, for instance, amount of sunlight, temperature, precipitation, to get a specific question that we can answer via an experiment. Just let this truck pass. And so once we have that good question form, that leads us naturally into hypothesis. You know, it's often described as an educated guess as to what is going on here, what's causing this phenomenon. To answer our question, we collect data. Most often in scientific studies, professional scientific studies, that's quantitative data, numbers, but often we can combine that with qualitative data, color, texture, sensory things that can't be quantified very easily and that are still extremely valuable for our studies. We then analyze the data, we throw it onto a graph, and we identify trends like what Mary Ellen was showing, or we'll map the data if we're looking at spatial data and look for spatial trends or patterns. And from that data and the analysis of the data, we can form conclusions about the phenomenon, about the question that we originally asked. And when we publish a report, when we present our work, we are almost presenting it as a story. Even though scientific papers have a formal format, introduction methods, it's still telling a narrative. It's setting you up with background information in that introduction and leading you through the steps of the process to ultimately arrive at a conclusion. And so if you just click the slide for me, Mary Ellen, I wanted to emphasize that ecology is particularly amenable to science storytelling because ecology is a branch of biology that deals with the relationships of organisms to one another, not only to each other, but to their settings, their physical surroundings. And so I often like to think of different organisms, different variables as characters in my story, and the natural environment as the setting. And we'll see this more through a direct example. Next slide, please. And here's the example, zebra mussels. Can I get a show of hands as to perhaps who's heard of zebra mussels in the Hudson River before? Paige, Amanda, Miguel. Somebody actually, if you're inspired, want to unmute and tell me what you know about zebra mussels, even if it's just a little bit? Yeah, Amanda.
I was gonna say just that they're an invasive species.
Yeah.
Don't know much more than that. They're dangerous.
They're dangerous because they're invasive.
Because they're invasive, yeah.
That's really the most important thing to know about zebra mussels is that they're invasive. And just in case folks aren't familiar with that term, invasive species are species that are non-native. So zebra mussels did not evolve in the Hudson River, despite loving it here. But they were introduced from, in this case, the Caspian Sea region in Eurasia. and they were transported to the Hudson River via the Great Lakes. There was a couple steps on their journey in the ballast waters of ships. So I'm not entirely sure what the physics of ballast waters is, but basically ships, when they're unloading and loading up cargo, they take in a certain amount of water to balance the weight of the ship. And so if you can imagine, you start in the Caspian Sea, you suck up all this water in your ship, and with that water, you get all of the different organisms that are in that water, including zebra mussels, which are tiny, by the way. They're the size of dimes, pretty much. You can see this person has a handful of zebra mussels in this upper left picture, sorry. And then when the ships arrive in whatever their destination is, they release all this ballast water, release organisms into the environment, and sometimes those organisms just, you know, it happens to be a perfect environment for them. And the Hudson River is like a zebra mussels paradise, namely because the Hudson River has so many phytoplankton and zooplankton, which is this right picture. So that looks like a big guy, but it's actually teeny, tiny, planktonic, very small. Zebra mussels are incredible filter feeders. They suck in water and extract the phytoplankton and zooplankton from that water. And they do this rapidly, and we'll see the effects of that later on. So that's some background on zebra mussels. They arrived in the Hudson River, and they were first seen in actually, if you go to the next slide, that might be a better way to introduce the chronology of zebra mussels. Yes, exactly. So this is a figure from one of the early papers, early studies on zebra mussels that was led by Carey Institute scientists. Zebra mussels in the Hudson River were first spotted in the early 90s, in 1991, at Catskill. And by the end of the year, they had already spread as far south as Newburgh. We have them in Kingston. That's what these black dots are symbolizing. And then only a year later, they had dominated almost the entire stretch of the Hudson. And if you go to the next slide, Mary Ellen. Actually, no. Oh, yes. Next slide is good. Yeah, so we can see this really rapid spread because of these ideal conditions for zebra mussels. But they're dangerous, like Amanda said, because for a couple reasons. But because they ingest so much phytoplankton, they really deplete the environment of that resource, and they outcompete other organisms. That's typically the issue with invasive species. They push native organisms out and they dominate an ecosystem. And you never want to have like a monoculture. You want to have diversity. I want to talk a little bit about the original study that produced the data that we're going to look at today. And what the scientists found when they were monitoring and collecting data on mussel density was very interesting. So even though the Hudson River presents an ideal environment for the zebra mussel, we don't see an endless infinity increase of zebra mussels over time. They're not just going to explode and keep exploding forever. What they're noticing, what the scientists noticed when they were monitoring the densities of new baby zebra mussels every year. How many new zebra mussels are being born every year? How fast is this population actually growing? What they noticed is that, okay, we have a huge spike of baby zebra mussels in 1992. By 93, there are fewer zebra mussels being born than there were the previous year, and even further in the following year. So what's happening here? What the scientists wrote, which I'm going to read out from the right side, is circumstantial evidence strongly suggests that the poor growth and recruitment of YOY, and YOY means young of the year, which is another term for baby mussels, in 1993 and 94 were caused by inadequate food supply. Filtration by zebra mussels reduced phytoplankton biomass in 92 through 94 to 10 to 20% of pre-invasion levels. The hypothesis that an inadequate food supply is limited zebra mussel growth and recruitment is consistent with the observations that both growth and recruitment were reduced after the phytoplankton crash. So what that excerpt is saying basically is that zebra mussels are consuming all of the phytoplankton and zooplankton that they possibly can in the river, and the phytoplankton populations don't have time to recuperate. So basically the zebra mussels completely deplete their own food source. So fewer baby zebra mussels can be supported every year. even though we see an increase generally in zebra mussel populations, the rate of that increase is slowing down because zebra mussels are depleting their own environment of their own food source at such a high rate. If you go to the next slide, please. Even more interesting is that when we, as scientists, continued to collect data into the 2000s, we see a much more interesting dynamic. Not only are zebra mussel populations increasing rapidly and then declining, but then they jump up again and then they decline again every few years. What's going on here? Why is this cyclic population dynamic happening? And it turns out that there is, of course, as we talked about in the previous slide, a direct relationship between zebra mussel populations and phytoplankton populations. And when zebra mussels hit a certain density at the at one of our peaks, then phytoplankton populations crash, and then soon after, zebra mussel populations crash because there's not enough food. But when zebra mussel populations are low enough, the few remaining phytoplankton that are still in the river can recuperate and revive their populations. We have a revival of phytoplankton, but then of course, the zebra mussels are like, now I have more food. I'm going to produce a lot more babies. And the whole cycle continues over and over and over again. And it's exhausting. And if you click the slide again, Mary Ellen, we can see I did a little inset of that graph that we just looked at in the previous slide of this little snapshot, zoom in the 1992 to 94 period. So we see this decreasing population growth rate as demonstrated, as shown by this little graph, this inset graph. And we can see that reflected in the big graph, the 1986 to 2014 graph. We see we have a really steep line at 1991 to 92. That line gets a little less steep because it's growing a slower rate, the population, from 92 to 94. And then we have the crash, the Great Zebra Mussel Crash of 1994. If you go to the next slide, that would be great. So here's where I want to have your opinion and your thoughts on this as librarians, as ELA teachers. If we were to tell the science story of the zebra mussel, how would we frame it as a narrative? Who are the characters in the story? What's the setting? What is the plot? What are the conflicts and what is the action that happens between our characters? And what changes by the end of our story? Although I gotta say, this story looks pretty unending because it's so cyclical. But if we were to tell this story, can I ask someone to share, who do you think are the characters that we need to introduce to our readers?
So you have your zebra mussels,
Mm-hmm.
you have the plankton.
Exactly.
And those are the two main characters.
Exactly. The two main characters. And the setting would be
The Hudson River.
The Hudson River. And I would say that it's not the most exciting plot because there isn't an end, but this plot which is driven by our conflict between and our dynamics between zebra mussels and phytoplankton, that is what produces our cyclical plot that we see with up, down, up, down, up, down. And then oh yes. Were you gonna say something, Amanda?
Go ahead.
Okay, yeah. No, and then I was gonna say that the change, there's not a clear change by the end of this story, but what we do know is that zebra mussels changed the Hudson River in huge ways. And so that could be what we consider the change at the end of our story, that zebra mussels were introduced in the early 90s, and then up until this point, and as in the foreseeable future, the Hudson River has been forever changed. Other organisms have been outcompeted. We have this endless cycle of population growth and decline, and the Hudson River is now, in large part defined by the presence of zebra mussels.
Well, and I would say not only that, but like my boyfriend and I, we do a lot of boating, and we go on like the jet skis and stuff a lot. So it's like wherever we go, especially like public lakes and stuff, like they're always, there's always a DEC representative there, and so they're like, have you been to any other lakes? Have you? So
right,
especially knowing you know, and I live right on the Hudson, I think, you know, so not that we've been in the Hudson, but it's like, that's exactly what they're looking for, because that's
Yes.
like the potential for a whole nother narrative when you start.
Isn't that, and in that, so I'm glad you brought that up, because, you know, humans can be a character in this story too, as vectors for spreading zebra mussels. Humans and their boats and what they do with their boats, you know, and that's really interesting. I actually didn't know that we had like monitors at different lakes asking about potential zebra mussel invasions, but that makes total sense because they're so easily spread and they can just attach themselves to the bottom of your boat or your jet ski, and they're so small that you can easily overlook them. So
Yeah.
that's a really interesting example.
Well, yeah, and you're talking about like the ballast waters and stuff, and knowing now that they're so small, it doesn't matter where, like it could just get into the boat, and
exactly.
So
Yeah, exactly. So there's a couple ways that the zebra mussel story has been told, because it became, as you might imagine, pretty famous, pretty well known, especially locally. You know, Amanda knows about zebra mussels, a couple of our other teachers have, because they're such a huge problem and because we as humans are such a significant player in this drama. And one great way to tell stories in ecology especially is through the food web. You know how I mentioned that ecology is the study of the relationships of organisms to one another and to their environment. So a great way to illustrate that is by a flow chart, or a food web that illustrates who's eating what, where does the waste go, how does that affect the environment, how does that affect other organisms. So here's a nice annotated food web of zebra mussel feeding dynamics and sort of the fate of their waste. You can go to the next slide. This is a less formal scientific diagram, but one that I love a lot. I love like a visually rich image like this. And I used to, when I was a kid, I used to love going to the Natural History Museum and looking at the dioramas that were like this, like sort of split, half underwater, half above. I was like, yes, I'm underwater with the fish. That's how I feel when I look at this picture. But this is a really beautiful illustration that we have at on the Carey Institute website of the Mid-Hudson Bridge and the estuary below, which shows just how persistent and opportunistic zebra mussels are. They clench onto anything. Other bivalves, you know, wood in the, that's, you know, stakes in the water. And we see that our fellow fish are really distressed. Mary Ellen, if you could point your cursor to our favorite fish.
This guy right here is my favorite fish because of the anxiety. He's so distraught. He's just realized, oh my God, zebra mussels are going to take over. Again, it just makes me laugh. I love the artistic rendering there. I feel you, buddy. We all have those days.
And I imagine if we were to plot the life of that fish on a graph, that would look quite different from the zebra mussel graph. As would any organism's life plot. And here in the middle, we have like a blown up, you know, this is not what they look like in real life, but this is, you know, microscopic zooplankton and phytoplankton. By the way, just to make, you know, those are big words, but they're really not that complicated. Zooplankton is like the animal plankton. And then phytoplankton is like algae, plants. They photosynthesize, hence phyto. But they're the same size. Zebra mussels eat both of them. They both exist in abundance. Well, not so much anymore in the Hudson. And you can go to the next slide, please. There's also, we can tell science stories literally as stories verbally. And I found this incredible article from 2000 in the early days of zebra mussel establishment, right when they were really starting to break into the news, where the Times author, Stevens, he in the title already starts us off by dramatizing the zebra mussel situation. He calls it an ecological melodrama. And I'm going to read this excerpt for you because it's really fun. Silently, mostly out of sight and unknown to all but a handful of the millions of people who live along the Hudson River, a subtle but elegant ecological drama is underway that may determine whether the revitalized river can continue its hard-won recovery from decades of pollution and degradation. The central player in this drama is the zebra mussel, a coin-sized, hard-shelled, black and white striped mollusk from Eurasia that hitchhiked to the Great Lakes aboard ocean-going ships in the late 1980s and has since been on the march in the waters of the northeastern United States. The mussels first appeared in the Hudson a decade ago. Their fluctuating population there is estimated at 500 billion to 600 billion in peak years. So I bolded the sort of more narrative elements that the author injects into the ecological story, you know, describing the Hudson River as you know, its actions as hard won. You know, the zebra mussel is the central player in our drama, like Amanda said. And I also think it's interesting that the author frames the Hudson River as a character in the story as well. The Hudson River is not just the setting. The Hudson River is also a character, which is fascinating, I think. On the march, you know, that's hitchhiked, all of these anthropomorphizing tools that the author uses to help us relate to and connect to the zebra mussel story. Because I don't know about you, but I don't relate to a little tiny clam or mussel, you know, naturally. But I like them, you know, visually. But you know, and so this, I think, was a really effective way of telling the science story. And we can go to the next slide. Hooray, movie screening time. So a little background on this. So I mentioned at my job at Carey Institute that my big thing is data visualization and data literacy. And one of the initiatives that we do at Carey Institute is this thing called the Data Jam. We've just finished our 7th year of the Data Jam competition. It is a competition in which high school and middle school students are challenged to look at a real scientific ecological data set from a study of the Hudson River. So it's all local data, big long-term data sets, and to identify trends in the data sets and then communicate those trends creatively through art. And so this was a winning submission a few years ago, meant to illustrate zebra mussel invasions in the Hudson River. And this was from Ossining High School students. And it's super impressive, really entertaining. And I think with that, we'll take it away, Mary Ellen. And we'll give you the thumbs up if we can hear it, because I can't hear it now. No, you might have to do the thing where you share computer audio.
Sorry, I was muted. Here we go again.
Hooray, I'll mute myself.
In a thriving aquatic ecosystem known as Ossining, life carried on as usual. Local primary consumers were able to consume their phytoplankton, dissolved oxygen was decent, turbidity was manageable, and everyone lived in harmony. Until the zebra mussels arrived.
Good morning, class. Today we're going to begin our notes on the human ecosystem. But first, I would like to introduce our new student, Mr. Zebra Mussel. Mr. Unidid. Mr. Unidid. Mr. Unidid. I'd like you to take Mr. Mussel after class to adjust him to the new ecosystem. What? Do it!
Pool has, you know, the usual like phytoplankton, platysterans, zooplankton. Oh, and rotifers. I love rotifers. Yes, it's such a coincidence. I love rotifers too.
Hey guys, it should really come down here. It's safe, they have plenty of food, work, really need to clean up this turbidity. Ooh, and they have rotifers!
Soon, Zebra Mussels' family and friends all settled in town. This figure shows zebra mussel populations over the years, and as you can see, they show no signs of stopping. With this data, we're able to see the extent of the zebra mussel's damage. Correlational analysis was performed on data that dates back to the late 1980s. This data suggests that the presence of zebra mussels does in fact have an influence on the population size of copepods. Some data do not show significant change, like this water transparency data. This data was provided by the Care Institute of Ecosystem Studies. Thank you.
Thank you, Mary Ellen. I love that. It never gets old for me. And I love how they set the zebra mussel story in a high school and introduce it as like zebra mussel's the new student and needs to get settled. And it's just people in zebra masks. I think it's really effective, and these students went a little deeper with the data set. They actually looked at specific species of other organisms. So like we have the unidid, which is this guy in the green shirt, who is competing with the zebra mussel for the phytoplankton, and rotifers, which are another microorganism that zebra mussels feast on. That's yet another way of telling the story of the zebra mussel and making it even more relatable to a high school audience. And you can do the next slide, please. And then, finally, although not finally, because there's always more ways to represent data, but one of the really powerful ways of telling a data story in a concise manner is the infographic, which is what we want to talk about today. So there are actually so few or like no infographics published about Hudson River zebra mussel invasions, but I did find this one from Texas because they're also a problem there, lo and behold. And what infographics do is they combine textual, visual, and then the data itself, so the numbers, to tell a full story using different types of sources and different types of media to enhance the experience. So different learners will respond differently to different things. I think that I'm a very visual learner. I really appreciate a nice graph. I appreciate not only a nice graph, but like even just an illustration to reiterate the importance of something. For instance, down here where it says 452 zebra mussels per square inch, and then talks a little bit about their densities. Yeah, thanks, Mary Ellen. You know, I like that it comes with this illustration that shows a beach crowded with zebra mussels. It's not a scientific figure, but it's still, you know, it's still reinforcing this theme to me and this idea by using both text, and this actually includes text, data, and image in just that little corner, because we have this figure of densities per square inch. And so what the infographic does is it uses a unified color scheme. It uses several different data sources often, yeah, to prove a point or to illustrate a central theme. So Mary Ellen, I would love for you to provide your definition of an infographic as well, because they're not always science related. They could be, infographics can be made for many things.
They sure can, India. Here we have a screenshot from a report that was recently published by Common Sense Media, one of my favorite nonprofit organizations that tracks digital literacy and the way that technology impacts children, youth, and education. This was conducted in March 2020, specifically around the digital divide, which is you know, the social phenomena of some students having adequate access to the internet and laptops and other students not having adequate access to those tools. As India was just saying, this is a combination of scientific figures and then visual illustrations of the meaning of those scientific figures, as well as text, to really give you a robust depiction of what the issue is. So in urban environments, they found 21% of students did not have adequate connectivity. In suburban environments, 25% of students didn't have adequate connectivity. 37% of rural students, so you start to get the picture that rural living students are facing a hardship when we go remote with schools, because almost 40% of them don't have everyday adequate access to the internet. We see similar figures when we break it down by race and ethnicity. We see that Black students and Native American students, by and large, are going to be facing the challenge of the digital divide more so than their white counterparts or even their Latina counterparts. The infograph really comes in when you look at this figure over here. So about 1 in 4 students still lack adequate internet. Here we have 4 different figures to represent the students, but 3 of the 4 have been kind of grayed out. So that would be illustrating people who don't have adequate internet. So here we're using images and color to represent this information. Right here, same kind of approach where we got 4 figures, 2 of them are bright and vivid, 2 of them are totally grayed out. That represents the fact that half the students in states with the largest divides lack internet, just don't have access to it or can't get on it regularly. Here we have a figure which doesn't represent information so much as illustrates information, which there's a crucial distinction. It's the difference between having a picture that goes along with the text and having a picture that represents the text or could replace the text in a pinch. And you know, this is just one set of data from one institution. One of the really neat things about working with the Carey Institute is that no matter where in the Hudson Valley you're teaching, somebody at the Carey Institute has done some sort of ecological study around there. So if you are in the Wallkill district, I'm sure there are sets of data that have been captured around your district. If you live in Millbrook, you're right down the road from the Carey Institute. If you live in New Paltz, you are going to have data about that as well. If you live in Ossining, you probably can walk down the block and look at all the zebra mussels that have attached themselves to various places. So big fan of the Carey Institute, big fan of using locally sourced data sets so that when you do data visualization with students, you're asking them to be thinking about data literally from their own backyard. And then one more quick illustration before we take a bio break, which is a new phrase I learned recently that I'm going to use to replace the term bathroom break. But these are 2 infographics that students at the Artifact created out of templates in Canva. Canva, which is spelled C-A-N-V-A. It can be used as an app on an iPad or a phone, or it could be used as a website. And they provide templates that make it super duper easy for you to plug in your information and use their visuals to make your point in illustrating the data. We did a project with the New York State Pollution Prevention Institute last year where we did a number of cleanups. We measured data on the kinds of trash and the amounts of trash that were pulled out. And then we created infographics to illustrate the severity of the Fallkill Creek's pollution to people. Wouldn't you know it, the thing that resonated with the teenagers the most is that there used to be more animals in the creek, but the animals have gone extinct from the creek. And the idea that something has been taken away from them by previous generations really motivated the teens. They were like, this is outrageous, we have to get the word out. So all these different color blocks, these come from the templates in Canva, which we will show you after the break. These are variations on stock images that are generated by Canva where they added the information to make it their own. And yeah, in the Fallkill Creek that runs through Poughkeepsie and Hyde Park and beyond, there used to be dwarf wedge mussels and bog turtles and New England cottontails and the Indiana bat. These species no longer populate the Fallkill Creek, unfortunately, but don't worry, they're not extinct from the world in general. They still exist elsewhere, just sadly not in the Fallkill Creek anymore. So we are going to take a quick break. It's 11:21. I think we'll maybe come back at 11:25-ish, but I would like to ask for you to think about during the break what you want to spend the next 30 to 35 minutes doing. If you are having a morning where you want to just do something mellow and low key, you can create a choropleth. We have a data set that you could use that just involves some coloring. These are very stressful times, so if you want to spend half an hour coloring something in, cool. If you want to dive a little deeper, maybe into some more intellectually rigorous stuff, we have a couple of options. We can take a poll right here amongst ourselves, and then we'll teach you how to use the apps to illustrate those results. You can just with a pencil and paper or in an app that we will show you, take your favorite book or movie and graph out the plot. Or, and this is really the deep dive for those who are so inclined, is to take a data set that we are going to give to you and then use one of the apps that we will cover to actually start creating an infographic and playing around. So we envision this to be more or less independent working time as you dive into the world of trying out how to visualize data. So as we go break, just think about what you want to do, and when we come back, we are going to ask for you to turn your mics on for just a minute to vocalize what you want to do, and we'll get started. And
Thanks, Ellen.
India, oh, you're very welcome. And I am going to put 3 minutes on the clock. Time to go get some water or coffee or breakfast. See you soon. Babe, did I hear you come down? Hi. I'll be right back. All right. I think once people start coming back, we will just jump on in.
Yes. You know, I've noticed that these digital avatars seem to be very popular among librarians. Meredith has her own little Bitmoji that she has in her email sign-offs, as does Aileen.
Yeah,
And Colleen has a digital avatar. I think it's so cute.
it is cute. Where do we get those from?
Many sources, I think. Oh, Alexa is eating a banana. I get it, Alexa.
Oh, I totally get it too. Totally.
I often turn my camera off, and also my mute. I mute myself when I'm eating on Zoom because I often eat crunchy things, so you can't have that ambient noise.
No, you can't. My favorite is when somebody has two different devices and one device picks up the other device and you get into this kind of weird feedback loop that sounds like robots in an argument with each other.
Which is kind of what it is.
Which is kind of All right, I guess we'll give another minute more for folks to come on back. And then, Jewel, in the meantime, would you like to launch the poll? All right, so we have some facts that we can give to you. We also thought it might be fun to take a poll amongst ourselves and then use the results of that poll as the data that we are trying to visualize and illustrate. So everyone should see a poll or a survey that just popped up. And please take that poll or survey. Did everybody see the survey pop up? All right.
I think that is the coolest Zoom feature, I gotta say.
It's a lot of fun. And if your district does not allow you to use Zoom, but you want to do a quick and easy poll with students, there is a website that you can use that is called Kahoot. Kahoot. I'm putting it into the chat, where you can build polls and quizzes, and they each have a unique URL that you send to students, and then students can be taking the same poll in real time if you don't have Zoom.
Mariella, it looks like it won't let me do it. I guess as a host, I can't do the poll.
I am afraid that, yeah, you need to be impartial as the host and the purveyor of the poll.
All right, all right.
And if everyone has responded, Jewel, you should see something that says share results at the bottom of the poll. Nice. And we got a comment in the chat from Paige that she actually loves all three methods for reading. It depends on your time and where you're reading. And that translates great to the scientific inquiry process, because if we were taking soil samples, it would matter what time of day it was and whether the soil sample was near a lake, up on a mountain, on a beach. Isn't that interesting? The majority of us enjoy reading a physical book the most, and we didn't have anybody whose preference was listening to audiobooks.
Actually, that would have been mine if I'd been allowed to do it.
Well, so let us then take the lesson also that data tell a story, and there's also probably more to the story depending on the data that is being measured, right? Fascinating. So we'll keep those results there, and then one by one, what do you think you would like to do for the breakout session first? Maybe, Indy, I will share my screen again, and if you could take a verbal poll on who wants to do what kind of breakout activity.
Yes. I'll wait till the screen is shared.
There you go.
Everyone has the options in front of them. So once again, we had we just took our digital poll, so we could practice using this real-time data and figuring out how we can best illustrate that. We can do some coloring, a relaxing yet informative and interesting experience for making choropleth maps. You could graph the plot of a book or a film that you love, Kurt Vonnegut style, which I'm very intrigued by. And by the way, if you want to do this or the choropleth, if you want to do it physically, of course, pen and paper would be necessary. And then for your choropleth, some nice colors, even if that's just like some different colored highlighters, that could also work. It doesn't have to be colored pencils or crayons. Or if you want to dive deep and actually try your hand at making an infographic. And so that's sort of like a more in-depth version of this first option, which is visualizing the poll that we just took. But if you actually want to try telling a data story, making a point, illustrating a concept, then we can dive right into the infographics softwares that Mary Ellen can show us, and then we can work through a data set together. So what do you think you want to do, Paige? And I'm calling on you first because you're the first person on my screen. I'm sorry not to put you on the spot.
I believe I would like to try the infographic, the last option.
Excellent. All right. And then what about, did Ashley say she would be right back? Yes. Okay, so I'll skip over Ashley. Miguel is next.
It's actually Fran. Miguel's my husband.
I was gonna guess. I didn't want to assume, but
yeah.
Sometimes your Zoom names come up differently.
Yeah. I think I would do the graph-a-plot.
Yeah. Awesome.
Great.
And then Alexa.
I'll probably do the infographic.
Nice. Colleen.
Infographic.
Cool. And then Ashley G.
Hi guys. I'll do the infographic.
Sweet. And then Megan's iPhone. Is that a participant? Do we have a Megan on the Zoom? Okay. If not, that's okay.
I'm not quite sure which Megan that is, or whether she is able to unmute and participate verbally. I don't know.
Okay.
And then Amanda said she needs to be right back in just a minute. Okay, so then, since mostly people want to do the infograph and Miguel, aka Fran, wants to do the graph plot, we're all going to use the same app. So then if you have an iPad, I would suggest that you download this free app from the App Store right now, Canva, or you can also go to canva.com. Right now, I am going to share an iPad screen just so you can see how it works. And we're just going to take a second.
Nice background.
Thank you.
Who is that?
This is a Diego Rivera fresco.
Beautiful.
Thank you. All right, so we see this app right here with the C. It's called Canva. That's what it'll look like when you download it or when you go to canva.com, and I am going to open it. Oh man. I'm going to do a single sign-on because I forgot what my password was. Single sign-on. Okay, new user. I'm just going to All right, so now we are in the home page of canva.com or the Canva app. All right, and what we're going to click, whether you are on your device or on a computer, is create a design up here. And we're going to do a quick search for infographic. And we're going to click on infographic. And it takes us to, oh, I always allow digital art apps to access my photos. If you would like to, you can always turn that off in your settings. All right, so we can see over here that there is a template that looks very much like the ones that my students use that we just saw before we took the break. Here we have a place where you can literally just delete the text that's already there, and we can add in our own text.
Sorry, Mary Ellen. I just want to address Alexa B. You said that the app looks different on your device. Is that what, did you say that? Yes. Is that okay?
I'll show you my iPad. It looks like completely different.
Whoa.
Is there a search bar anywhere on there?
Yeah, there is. And like I've used Canva before. Like I usually just do it on like my regular computer. I guess I downloaded the app a while ago and I don't even remember doing it. But like when I search for like infographic, I don't know, it just doesn't look like yours looks like the website, but in app form. Yeah. Mine looks like completely different, which is fine. I'll figure it out. But I don't know if anybody else was having the issue.
Yeah, does anybody else have a different setup than what I'm showing? Oh, I'm sorry, Alexa. Well, I guess today's your lucky day. Yeah, I don't know. you get a little bit of a different challenge. And if you want to share your screen in just a second, I would be happy to work with you more specifically on navigating what you have in front of you. Right now, I'm just trying to show everybody that if you're taking a very text-heavy findings or data set that you want to convey, this is a great template to use because it has large blocks of text built in where you just delete the text that's in there and you replace it with your own text. So now if you wanted to take, India, you had a statistic that we were going to use, right? Could you pop it into the chat, please?
Into the chat, absolutely. Give me just a second. I'm going to mute myself again.
Sure, there are all kinds of different templates. If you want to do one that is more about urban designing, they have a ton of those. If you think that you might want to do one that is more about shopping, then you would go in there. So I'm going to use this one just to do an example for, what was it, 83% of us said that we prefer physical books. So I would, if I was a student of yours trying to convey that, I would maybe just pop in here. This is shift percentage of us who prefer. Okay, and then if you click on this graph, this pie chart, you drag it off the screen to get rid of it. Or if you want to hit undo, there's a little arrow up towards the left right next to where it says resize that makes a little whoop go back. So here it would be like, and you see how clicking on the pie chart opened up this little table towards the top left? So I would input physical book. And that was 83%, right? And this was digital book. And that brings us to 17%. So then you would spend some time playing around with how you want to line up all these different shapes. And it is really just about spending time with your data, figuring out what you want to say, and then figuring out how you are going to represent it visually using all of these fun little tools and elements and assets. So say that you didn't necessarily want to start with a template, but rather you wanted to start with some kind of funky background that is part of the free Canva package. You would just kind of shop around. And then say, for example, that you're thinking, well, all of those things that are pre-supplied are pretty cool, but I want to add something of my own. There are different starter charts, grids, gradients, clip art, so to speak. This is a really neat thing over here because you can make your own table. You know what? I'm going to delete some of this stuff because I want to get a nice blank background going. Yeah, I put it in the wrong place, so now I have to delete it in order to get it out of there. All right. Nope, not all right. Get me out of this template. Oh, this is a real straightforward one where if you wanted to do something like that image that India showed us where 1992, there were only like 5 places on the Hudson that zebra mussels were located as compared to 1996 where there was a million different places where the zebra mussels were connected, you might use one like this. You can also start by using a photo as a background. Now they give you some photos, but also you would be able to access your own camera roll and use photos that you yourself had taken. All right, so we see here, India, can you read us through the fact set that you laid out?
Absolutely, yeah. This is an excerpt from a press release about zebra mussels that has a nice condensed chunk of facts and very sort of impactful statistics. And a truck is about to round the corner. All right, there it goes. Great. Okay, now I'm going to speak. Okay, zebra mussels first appeared in the Hudson in May of 1991. Since September 1992, zebra mussels have been dominant in the freshwater tidal Hudson, constituting more than half of the heterotrophic biomass, which means their biomass refers to not the populations of organisms, but more the literal mass that the organisms take up. So when we're saying that zebra mussels constitute more than half of the heterotrophic biomass, that means that the volume and density of zebra mussels is over half of all the other stuff in the Hudson River combined, living things. And they filter a volume of water equal to all of the water in the Hudson River estuary every 1 to 4 days during the summer. That is huge. So that means that every 1 to 4 days, you can imagine a whole new, you know, body of water is being expelled by these zebra mussels into the Hudson River. They're taking all the water, filtering it, passing it through their systems every 1 to 4 days, which is an unbelievably fast rate. As a direct result of, as a result of direct consumption, phytoplankton biomass fell by 80% and zooplankton numbers fell by 70%. So we have a couple like very concrete numbers, and they're very significant and big, and they lend themselves well to sort of telling the dramatic story of the zebra mussel. So there's a couple things we can do. We can do a timeline, like Mary Ellen showed us a timeline or a linear infographic just now. So we can employ timelines to tell the chronological story of zebra mussels, and we can pull out some more data from our graph to get a more complete picture of the zebra mussel invasion. Or we can focus on the early years of the establishment of zebra mussels in the early 90s. Another thing we can do is pull out this statistic, more than half of heterotrophic biomass. So that's not a specific number, but we could use, you know, what Mary Ellen was talking about. We can use an illustration rather than a scientific figure or graph to show, to sort of illustrate that. So I don't know if I said that in a way that made sense, Mary Ellen, but if you actually zoom in on this principles of urbanism, these 3 icons, I think that's really what I was trying to refer to is, you know, rather than, because we don't have a number to create a graph, we'll instead use imagery to emphasize, you know, that zebra mussels constitute or more than half of heterotrophic biomass. Every 1 to 4 days, that's a huge number that we should be putting in, and we should also, if we can, if we're interested, figure out what exactly that volume of water is in the estuary to further emphasize how impactful zebra mussel filter feeding is on the ecosystem. And then finally, we have this last sentence, phytoplankton biomass fell by 80%. And zooplankton numbers fell by 70%. So another important thing that we should consider when we're making infographics, especially about this, is that when we're dealing with subject matter and with subjects that are probably unfamiliar to our audience, like I don't really know off the top of my head what a zooplankton looks like. It's going to be important for us to add images of not only the zooplankton and the phytoplankton, but zebra mussels themselves, and also to emphasize what the scales of these organisms are. So we talked about how zebra mussels are only the size of a dime, but you wouldn't know that unless you had that picture of the zebra mussels in someone's hand for context. So it's going to be also important to just really put an image in your viewer's mind about what exactly it is we're talking about. That's only going to enhance their experience even more. And then perhaps including a photo of the Hudson River estuary environment. We want to place the viewer into the story, into the setting. And Mary Ellen, do these numbers look good to you?
They do. So I was just sort of illustrating how once you have numbers and information that you're trying to convey in Canva, you would just jump in and start replacing the kind of holder info in a template with the info that you want to use. Now, in addition to Canva, there's one other app I want to draw your attention to.
Oh, because it's already 11:51.
I know. Time flies when you're visualizing data. This is an app called Icon Graph. And like most apps, it has free options and it has paid options. Whenever we're doing work with students, we always try to go for a free one. But say that this is what you want to do. Now there's a different fact that I was going to use, which is that the average American teenager spends about 9 hours on their phones each day, or some kind of screen, which, you know, it blows my mind. But so 9 hours out of 24 hours, someone who's better than me at math. What is that? That's 3/8? 3/8 of a day. I don't know what percentage 3/8 is, but I know the scientists will be disappointed in me for not being able to do this in my head. Sorry, everybody. 3 divided by 8 is, okay. That is 37.5%. So I would say for my title, hours per day. Oh, nope. Actually, no, it's not hours per day that I am measuring. It's time per day. Because it's a percentage, not a number of hours. Time per day, that would be 37. And then I need to get even more specific, don't I? It's time per day on a phone. And then say that I thought to myself, I don't really like that tree icon for this. I'm going to look through the library of free icons provided by the Icon Graph app, and I am going to think, what really illustrates kids being on a phone? Maybe I should look under book, school, study. Nope. I don't think that does quite the job either.
I just saw one go down. The chat, if you go even further down. Yeah, chat social talk.
There we go. Nice. So, and you can add additional text boxes. You can add additional, well, you can play around with different colors. Like say you want to make the background a different color. Icon Graph is maybe a more rudimentary kind of infograph that you would be building as opposed to Canva, but it also makes it very, very easy for you to do one of these. I guess there's a limit to how much text you can put in. You can alter the thickness of your pie graph. You can choose to put the title on or off. You can change the aspect ratio even. So the real work of data visualization is in figuring out what that story behind the data is, which we showed you some very quick warm-up activities to help you wrap your mind around how do we get at the story behind the numbers and how do we tell that story visually. For a little more something in depth, like Indy walked us through the zebra mussels story, you could get a data set off the Carey Institute website and you could show your students the raw numbers and walk them through the process of making a graph and then coming to a conclusion and then trying to illustrate that conclusion through visuals. We don't have a whole lot of time left, but Indy, do you want to take back the share over and show them where the data sets on the Carey Institute website are?
Yeah, I would. Okay, let me quickly pull up something before I share. Okay, here I am, careyinstitute.org. Eco inquiry. We're going to go to Data Jam competition. You could also probably just Google Carey Institute Data Jam to lead you to this page, which has our friend, Mr. Zebra Mussel. Again, a famous Data Jam submission. And then if we go to the right-hand side of the page, we've got this gray box, and then we have data sets. And then here is where all of the Carey Institute data sets live. So these, as I mentioned, are real data from real scientific studies done in and around the Hudson Valley. So it's all local scientific data for us. And we divide our data sets into 3 levels. Level 1 would be the easiest to interpret. only a few variables. A really clear trend is illustrated in the data. And again, fairly easy to tell that story. So the zebra mussels are a level 1 data set, which is not to say that it's less valuable, but it's good for introductory learners and students who are just starting with data literacy and data exploration. Level 2 is a little more complicated, and then level 3 is our most difficult, most challenging to interpret. Multiple variables, the trends are murkier. It requires a lot more, bold interpretation, I think, to make claims about our level 3 data sets, but they're still really interesting to look at. And this is not only Carey Institute science, we also get data sets from the DEC, from Riverkeeper, we have some data sets from Vassar and Marist, and the DEP, Department of Environmental Protection. So there's a ton of different types of data, not only organismal, but we have, water chemistry, we have hydrology, temperature, climate change. So there's a whole bunch of data. And then I also want to show you this incredible tool that we recently acquired for visualizing data. It's called Tuba. This is free. This link is, the data that's, to get a Tuba account costs money, but to actually use Tuba is free. But if you were to upload your own data sets, you'd have to upgrade. But anyway, all of our data sets that I just showed you on the website are also on Tuba. And what you can do with Tuba, let me find our zebra mussel data set, I think is all the way at the bottom. Yep. What you can do with Tuba is you're presented with background information as soon as you click on a data set. And then we've got all these points scattered about. These are all of our data, but there are no variables on either axis yet. So I can drag and drop my variables or my attributes from the left-hand side into the axis I want. So I've got year on the x-axis, which is typical. And then I'll do zebra mussel density on the y-axis, just drag and drop. And then the software automatically graphs the data for you. And right now this is a dot plot, but I want to make this a line graph because that's more appropriate for chronological data.
Isn't that awesome?
And here we are.
And
then there is the graph that I showed you this graph in, I just need to get the door real quick. 1 second, sorry. Sorry about that. But this is the graph that I showed you originally in our presentation, and you can see that, like in just a few seconds, without any futzing on Google Sheets or Excel, you can create a powerful data visualization that is much more impactful than simply a spreadsheet of numbers. So I realize it's 12 and we might need to wrap up, but I'm glad I got to show you that, and we'll be able to send links to participants as well for all of these resources. And if you're interested in having your class participate in Data Jam as sort of part of a data visualization lesson, then you can also reach out to me. We can talk about that. But yeah.
And everybody, I'm going to put my email into the chat because I realized we didn't actually get to do independent work very much. If anybody would like to reach out to me and schedule kind of a one-on-one tutorial through different apps, please do. I am here for you. You can also email India if you want to get more of a one-on-one walkthrough of the scientific process. And then I guess that wraps up the story and the data for the day. Thank you all for being here with us today. Yeah, let's give them a round of applause.
Thank you, teacher, the librarians.
Between literature and science, you are changing the world. Thank you for doing what you do. I know this is going to be a weird and unusual and probably tough year. Please hang in there. We're all rooting for you, and it's so important what you're doing. There is a Google survey form that Jewel just popped into the chat. We would like to ask you to take this survey. Completing this survey and giving us feedback on how things went today will generate for you the evidence of attending that you might need to get your mylearningplan.com credits or to give your district proof that you attended 2 hours of PD today. So please go ahead and take that survey. Thank you again. Reach out to us for anything that you might need. And I guess back to you, Jewel.
Okay, well, yes, I was just going to encourage everyone to please complete the Google form. I will be contacting all the districts with the attendance verification. So it's not anything that you have to do other than fill out the form, and then I'll send that off to your districts. So I think that is it. If anybody has questions, you'll be hearing from me. I'll be sending you the presentation and the recording. And so you can always just, email back any questions that you have. But thank you so much to India. Thank you to Mary Ellen. And thank you to all of you for participating today. Have a great day.
Have a great day.
Thank you all.
Bye.
Bye.